Yesterday, or in our last set of videos, we saw how to solve a system of equations in three variables and what that means. Today, we are going to work with word problems involving systems of equations with three variables. So I'm going to call this example 2a. So we did example 1 when we were solving. Word problems with systems in three variables. All right, lots of words here. So again, you're an office furniture distributor. You have a budget of $7,200 for 80 new chairs. You can choose from leather, that cost $125, mesh are $100, fabric chairs are $75. You want 3 times as many fabric chairs as leather. How many of each type should you buy? Just kind of in general as a tip, if you are ever not sure what your variables should represent, look to the question. The question at the very end will give you our hint. How many of each type should you buy? Each type of chair, those are our variables here. We have 3 types of chairs. We're going to have 3 variables. So I'm just going to use the, I guess, normal x, y, and z variables. And I'm going to use x to represent, and I'll just go in order, the number of leather chairs. And I'll use y to represent the number of mesh chairs. And then z to represent the number of fabric. And then you can kind of sort through your information and try to group like information together. So just looking right away, I have all of these dollar amounts. I have $7,200 and $125 each, $100 each, $75 each. So put this information together to get an equation. $125 for each leather is 125x. $100 for each mesh is 100y. $75 for each fabric is plus 75z. And we have $7,200 total. All right, money, we've used all of that. Now we have 80 new chairs that we want to buy. Well, 80 new chairs, if we're buying 80 total, that's our number of leather, number of mesh, and number of fabric all added together. So this one is just x plus y plus z equals 80. And then our last piece of important information, let's see, use a different color here. We want 3 times as many fabric chairs as leather. All right, let's think about this for a second and how we're going to write this. Okay, let's say I have 20 leather chairs. That means I'm going to have 60 fabric. For example, 20 leather and 60 fabric. So our number of fabric chairs was 3 times the number of leather. Okay, so again, our number of fabric chairs, Z, was 3 times the amount of leather. So Z equals 3x is my third equation. So this gives us all 3 equations. My system of 3 variables should have 3 equations. Now we can get started and solve. Okay. Now, important thing to keep in mind, not every equation is going to have every variable in it. Just like this bottom one, we don't have a y. All right, at this point, we can work our problem out a couple different ways. I guess one of the first things I notice is that my bottom equation doesn't have a y, and I have my z equaling something else. So even though we talked about how elimination can be really, really helpful to solve systems of equations in 3 variables, when you have something like this, we have one variable by itself, and it just equals one other thing. Substitution is actually really easy. So I'm going to show you guys substitution to solve this system. because I can substitute this in really nicely. All right, so z equals 3x. Everywhere I see a z, I'm going to put my 3x here. And this will actually eliminate our z variable as well. All right, so my top equation becomes 125x plus 100y plus 75, but instead of z, I have 3x equals 7,200. And let's see, what can I do with that? 75 times 3x is 225x. And then I can combine 125x and 225x to make 350x plus 100y equals 7,200. Now at this point, I just noticed, hey, everything ends in a 0. Let's divide by 10, and that'll just make my numbers a little bit smaller to work with in the future. So divide everything by 10, it gives me 35x plus 10y equals 720. And we still have some big numbers here, but this will make it a little bit easier maybe. Okay, substitute this z equals 3x into my middle equation here. X plus y plus, but instead of z, I'm going to use 3x equals 80. X plus 3x is 4x. And I get 4x plus y equals 80. All right, so these two equations I want to solve together. And I guess one other thing I can notice too, 35x plus 10y equals 720. I could, if I wanted to, divide everything by 5, and that would still make my numbers a little bit smaller. It's really not a big deal though. You definitely don't have to do that. All right. Let's look at these two equations now. I'll switch colors. These two equations have two variables. Let's solve these together. And like I mentioned, that top equation, I can divide by 5. I'm going to do that just to make my numbers a little bit easier to work with. And that would give me 7x plus 2y equals 144. All right, so I'm actually really close to being able to eliminate something here. I have a 2y and a y. If I multiply this bottom equation by 2, then I'll have 2y in both places. So top equation hasn't changed yet. This bottom equation, 2 times 4x is 8x, plus 2y equals 2 times 80 is 160. Okay, to get my 2y's to cancel out now, I have to subtract everything straight down. 7x minus 8x is negative 1x. 2y minus 2y cancels. 144 minus 160 is negative 16. So x has to equal positive 16. All right, so if x is positive 16, and I know z equals 3x, z equals 3 times 16, which is 48. And then last, x plus y plus z all together has to equal 80. Let's plug that in. X plus y plus z equals 80. 16 plus 48 is 64. Subtract 64 from both sides. That means we also have 16. 16y, which is our number of mesh chairs. So altogether, our answer, we would have 16 X's, so 16 leather chairs. We would have 16 mesh chairs and 48 fabric chairs. Okay, so just like before, making sure your work stays organized is a really big advantage when you're solving your systems with 3 variables, especially with word problems.